Okay, so right now we have the VRX set to 120 volts. As you can see on the multimeter, it's showing 119.4. On here is 120. We're going to adjust the variac to a positive voltage well past the 130 mark, and we're going to see what it says here. And right here, if you heard it click, it shows that the input's 127 volts, and the UPS immediately dropped it to 113, well within a safe range. We're going to keep dialing it, and we're going to watch here, see what it says at the APC UPS. 130, output's 117, 134, turns to 119, cranked up to 138, we're at 140, the UPS is still at a stable 124, and we'll max it all the way out. And you heard it click again. It's showing went straight into battery instead of into AVR. And the output straight from the battery is 120, a solid 120. The input voltage is a very high 147. Let's see where it cuts off. So approximately 135 volts. It cuts back into AVR mode. So that's basically the internal electronics, not on battery, is compensating to provide an output, a rock steady 120. Right there. And currently the voltage is 135 from the variac. Let's drop it back down. You hear that click? Input's 128 and the output's 114. It clicked again, so I dropped the voltage. Input's 122. It very much mirrors what it is. Let's go in the opposite. We're at 112, 110. Still within the safe range of any electronics. And you heard it click again. So it looks like 109. So as I expect, approximately the cutoff is 110, which is a standard in North America. It's 110, 120 to approximately 130, which is well within a safe range for any electronics. So the output mirrors 111 for the input versus the output. And let's hear the click. Voltage is well below the 110 mark, and it goes straight into AVR mode. But it says the output for electronics for voltage is 122, which is fantastic. .97 volts input. Another click. Still within working in AVR mode, not on battery. So 92 volts. And the output from the battery pack, or sorry, from the UPS is 120. We're currently at 88 volts. .82. The system kicked in out of AVR, directing into battery output. So the cutoff was approximately around 83 volts, which is well too low. But you can see the output is a rock steady 119, 120. Let's keep dropping her. 71. 64. 53 volts. 42. And it's for shit and giggles, right down to 0. So that's mirroring obviously a blackout or complete loss of line power. So when this thing's on battery, it's a rock steady 120 volts, 60 hertz. And let's see where it kicks in before it goes off a battery pack. It'd probably be around 80 something volts. .85 volts. So this UPS can compensate internally before going battery pack at 85 volts, which is extremely low. That's outstanding. The next relay kicked in. So either a boost or buck. Now another boost. And I have it here at, again, approximately 120 volts AC. So this UPS, this specific model and unit, has passed my AVR load test, a lull or sag, as well as a surge or a high voltage input. So these are all the things, the validations and the checks that I do on all units before I commission them to ensure real world that if the lights go out or there's a huge swing in voltages, that the electronics that are attached to these devices are safe in terms of operating well within its safe limits, but there's no way for something to impact and reduce their life expectancy or their performance. And that's something I encourage everybody to do when they get anything. Don't take it as gospel from the vendor that X will operate when Y occurs. You need to validate, you need to test, you need to confirm that the advert matches real life, real world experiences, because there are a lot of makers, including APC, where something has, basically, unfortunately, gotten past them. There are brands, it doesn't matter what you name, whether it be APC, Tripolite, Cyberpower, Eaton, etc. Every brand, every model has been something that's happened in the past that has impacted, to the consumer. Something's been burnt out. Let the magic smoke out. That's why, again, I encourage everybody to check, test, validate, and always do another test to make sure ongoing that what you have is still operating as you expect. And keep in mind, these devices are very much like shoes, underwear, brakes. Things wear, things break down. So it's important that this device, depending on how you set it up, I have mine set to do its own check every day, every 12 hours. And I've only done that to ensure that before I commission everything, that it does its load test, it's ensuring that the post comes up, everything, because I have tens of thousands of dollars worth of equipment that will be connected, and I want to make sure before I connect anything that all of these battery packs and the UPSs can provide me that important backup and redundancy and protect all that expensive electronics. So next one, I'm going to follow up with some of the other devices I have in the house that provide similar but on a smaller scale. All right, be right back.